introduced the start of our lab a little bit, but I wanted to take a brief moment to also introduce the team in our lab. We have 4 students shown here, Cindy, Catalina, Daniel, and Michaela, who make up our research unit and are the primary producers of all the work I'm about to show. Thank you all for your hard work putting up with me and making our lab an enjoyable place to work. Moving on to what we do, the CC research unit started last year, primarily in the fall, with an aim to solve the question of how we can transition from building buildings to assembling buildings. With that goal in mind, we created a few separate research tracks ranging from 3D scanning and augmented reality to 3D printing and understanding how sustainability and financing can be aligned rather than working in constant tension. With the preliminary tracks in place, we've grown quite a bit in our reach, working with various corporate collaborators within these tracks, from Reconstruct and Azimuth to some of the panelists we have here today with Admix Innovations and Cobod. We've also collaborated with a few other institutions and with researchers at the University of Illinois and Cornell. We're also currently applying our research in a fabrication course this semester with some of my students here, focusing on 3D printing public scale furniture, which we hope to install in a project in Doral this summer. And finally, we've planned our next few research lines of digital twins, automating construction pricing and scheduling, and tracking design for manufacturing, which we hope will help us solve our initial prompt of transitioning into assembling buildings. Starting with our work in 3D printing, this is a townhouse project we've been designing in collaboration with Harmony Homes and Cobod. The project explores how the deployment of a 3D printer can reduce the cost and increase speed of construction for townhouses within the infill housing requirements in Miami-Dade County. One of the key interests for the project, shown on the right-hand image, is how the 3D printer can be used to create unique forms and textures to increase the quality of design, in addition to lowering the cost. In our case, we are trying to design a wall texture that encourages plant growth by producing curved texture that plants can grip onto as they grow. The courtyard shown in the photo also acts as a natural splitting point in the 3D printing process that we can use to shift the printer from one location to the next to continue printing the house. We've also been looking at 3D printing at smaller scale installations. This project was a collaboration with Colombian artist Francisco Millán in Coral Gables. The project consists of a tetrahelix, which is a geometrical composition that essentially allows you to stack a series of tetrahedrons where all of them will have a unique orientation in space, while also maintaining a center of gravity that allows you to build a tall structure that uses very minimal additional supports. Our interest in this was also to explore the layering of the concrete 3D printing process, and in this case, kind of use this art piece to show each layer of the 3D printing per each tetrahedron, oriented in a different orientation, so that as you walk around the sculpture, you see the layering kind of composed in different orientations and views. The last 3D printing project I'll show is our current work looking at topological optimization for concrete structures. In this case, we're using topology algorithms to loop through and optimize column forms to use the minimum amount of concrete needed to support a given set of loads. While this type of computation has existed for quite a bit of time, the resulting forms are complex and costly to manufacture, but we believe that may change by being able to 3D print the formwork for the structures, CNC bend rebar into exact locations, which you can see an early example that we started 3D printing earlier this week. Moving to our work in augmented reality, this project was an XR grant submission for a grant hosted by the IDSC that enabled users of concrete 3D printers to be able to control multiple aspects of the 3D printing and concrete mixing process via extended reality. In this case, we took information from the mixing pumps such as water content and admixture ratios, as well as printing information such as speed and material flow, and tried to enable remote control of these so that one user could simultaneously watch the printhead while controlling many aspects of the machine, a process that typically takes multiple employees. The final project I'll touch on was a partnership with the University of Illinois and a platform called Reconstruct, and mostly a researcher named Juan Diego Nunez Morales. The project, which we will continue in the fall on a new CC project in Doral, aimed to move away from expensive LiDAR and laser scanning in favor of using something every construction worker already has on site, a cell phone. Here we uploaded a very detailed BIM model to the cloud, documented the site with iPhone photos and videos, reconstructed a 3D model using photogrammetry in the Reconstruct platform, and then use that to automate and color code potential deviations from the model that site supers could review and decide if the discrepancy was cause for concern. The image at the bottom shows a notification from the process in one of the first unit build-outs that pipes may be located outside of the given tolerances. We are currently working on expanding this research to target the location of plumbing sleeves prior to pours to eliminate core drilling in the slabs, early visual potential collision detection, and verifying locations of rough edges. Thanks for taking the time to join us, and I think we can start the panel now.